topic. Okay, difficult in a sense that we will be talking, okay, about this topic, okay, from mathematical point of view most of the time. Okay, so actually mathematics is what may be a problem, oops, for this topic. Otherwise it is not difficult. Okay, so that's what I wanted to say. So mathematics part of this topic is actually difficult. Okay, otherwise it's not that difficult at all. I should not say at all it is difficult, but it is difficult to some extent. Okay, then yeah, but we will go slowly. At least we will understand the concepts of what is going on, and also it should be not that difficult also. Okay, it should be fine. Okay, so let's just check. Okay, see, so first of all, of course we are not going to touch everything. Of course, today we will only start with oscillations. Waves is the totally different topic, so we will take up it next time. No, today are not possible, of course. Oscillations also I don't think so I will be able to finish today, but little bit of course we can start off with. Okay, see, now we have already learned about different kind of motions. Okay, see, there are different kind of motions. One is linear motion. Another name for linear motion is rectilinear motion. I think you are aware of that. Rectilinear motion, or just linear motion, where an object is just going to be in a straight line. Okay, it can go to the right, the object can go to the left. Okay, so that's your linear motion. We have, apart from it, rotational motion also. You know what is rotational motion. I don't have to write it down right now, but we have a different set of motions also that we can talk about today. Okay, and that is this one. See, today we are going to talk about something called periodic motions. Okay, see, this is the first thing. Okay, number one, today we are going to learn something called periodic motion. Okay, so what are periodic motions? See, if the motion of an object, okay, is repeated, I don't know the spelling of repeated. Okay, repetition, okay, if there's a repetition in the motion of the object, okay, then we will call it what motion, guys? We will call it periodic motion. Okay, I can give you example, then things will become clear. See, example is the best example is this. See, we have sun, of course, big sun, and we have earth. We have earth, and we know something about this, right? We have earth and sun, and we know about the system. Okay, the earth is going to go round around the sun, and it will reach back, okay, to that location, okay, to one position with respect to sun is going to reach back. Okay, and then you know what, how much time it takes, guys, to complete one revolution around the sun? You know the time also, right? Around how many days? 365.25 also is there. Okay, point something. It's not exactly 365 days. Okay, or 6 hours. Look at him, he knows. Okay, so let's say 365 days. Okay, that means the earth is going to go back. Okay, not go back, it's going to take one round, but after that it's going to do the same thing. It's going to repeat its motion, right? It's going to do the same thing, not anything different. Okay, and yeah, this we are going to call it what motion, guys? We are going to call it repetitive motion, because the object is really repeating its motion. Okay, doing the same thing over and again. Okay, and yeah, we will group it in what kind of motion, guys? We will call it periodic motion. Okay, so every periodic motion, okay, will have this time, the time after which the motion is repeated, right? That time we call it time period. So every periodic motion, don't forget, it will have something called what, guys? Time period. Example is this, the time period of the earth going around the sun is 365 days. After that, it means that after 365 days the motion will be repeated. Okay, any other example, guys, can you give me of repetitive motion or periodic motion? Yes, some more examples. Pendulum also very good. Number 3. Oh, sorry, not number 3. One more example is pendulum. Okay, check. If I start, no, a pendulum from this position, okay, is going to fall down, reach this position, let's call it X. Okay, will go up, reach this position called Y. It started from, let's say, W. Okay, then what will happen, guys? From W is going to go to X. From X it will go to Y. It will go back to what? X. It will go back to W. No, this is what happens. Okay, after reaching W, it will again go to X. Now the motion is repeated. Look at this. This was the motion from W to X. Now again, this is again a motion from W to X. Okay, this is going to be repetitive. Okay, so your pendulum is another example of repetitive motion. We can call it periodic motion. Your pendulum, okay, is another example of another category. Look here. Now we have another category of motion, okay, which we call it oscillatory motion. See, oscillatory motion. I think I can go directly now to your oscillatory motion. Okay, see, the best example is pendulum only for your oscillatory motion. This happens. See, if I have a point, and you know what, the object the object that I'm talking, okay, goes back and forth about this point, okay, that means it's going to go back and forth about this point, means this is the point, this is another point here, let's say A around this point, okay, we have a point A, and let's say we have another point here B around this point, right? So the object that I'm talking about, okay, this is not the object, this is point O. Let's say this is the object, check, this is the object. This object, you know what it does? It goes to the left of this point called O, it goes to the right of this point called O, okay, it goes back and forth like this. So you tell me guys, okay, can I call it repetitive motion or not? Check.
Yes, sir.
It's going
Yes,
back
sir.
and forth, so it is a repetitive motion, okay. But apart from being repetitive motion, okay, another name now I can call it, right? What do I call it now? Another category, what is that? Oscillatory motion, okay. And I really need to show you, okay, when does the motion actually repeats here, that's I really have to show you properly. So please check, okay, so check, see, okay, let's say our object has started from this point called A, okay. I could have shown you from O also, but let's say from A, okay. So suppose the object goes first from A towards O. Look at this, the object goes from where to where? A towards point O, okay. Tell me, the object has started this motion or repeated this motion or not repeated this motion till now?
Not repeated.
They did not repeat this motion till now, okay. Then the object, okay, after reaching O, the object goes from where to where? O to B, okay. Tell me, is the motion repeated or not repeated?
Not repeated.
Not repeated,
Not
okay.
repeated.
I'm also going to write some timings, okay. 1 second, and suppose again another time, 1 second, okay. To go from A to O, 1 second, O to B, 1 second, okay. Now the object goes from where to where? From B where, guys? From B to O. Tell me, is the motion repeated or not?
Yes, sir.
Yes, sir.
No, still no. I knew it, okay. Some of you might will have problem. Going from O to B is not same as going from where to where?
B to
B
A.
to A. So the motion is not repeated till now. Can you understand? This is not
Yes,
called
sir.
repetition till now. This is not yet
Sir.
repetition. Yes, yes.
So the motion is repeated in terms of O to B.
That's not how we should speak actually. See, the object is going from O to B. Now the object is going from where to where? B to O.
O.
If the object has gone from O to B, again O to B, then I'll say, yeah, motion is repeated, no?
Yes, sir.
Okay, okay. Going to the right is not same as going to the left, no? So that's why, okay, it's not same, okay. So yeah, now what will happen, guys? Tell me, where is the object right now? It has reached where now? O, right?
Point O.
Point O, okay. Now the object goes from O to A. Okay, from O to A. Tell me, is the motion repeated or not? Let's say another 1 second later, okay. Tell me, is the motion
Yes,
repeated
sir.
or not? No, not yet repeated, no. Not yet repeated. Do you agree?
Yes, sir.
Okay. Now the object has reached where? Point?
A.
Point A again. Now if the object goes again from where to where?
A to O.
A to O.
O to
Now,
B.
now A to O. First, let's say A to O, right? Then do you agree that the motion is repeated or not? Look at these two. This is also A to
Yes, sir.
A to O, and now this is also again backward. A to O. Now the motion is what? Now the motion is repeated. Can you understand? All of you got my point, I think, no? What I'm trying to say?
Yes, sir.
Okay. Yeah, so this took how much time? 1 second. This took how much time? 1 second. This took how much time? 1 second. This took how much time? 1 second, right? After how many seconds do you think the motion is repeated now? After how many seconds?
4 seconds.
4 seconds. So this 4 seconds, we have to call it what, guys? We have to call it time period, right? Okay, okay.
Yes.
I think you got the point. Okay, let me show you again one more time. Okay, not the same thing, of course. I'll show you a different way of looking at this now. So suppose I tell you this is happening now. Okay, let's check. Okay, let me rub everything. Okay, so let's start from the beginning. See, let's say our points are this one O, this is point B, and this is point A. Okay, let's take our object. This is the red object. See, this is the object now. Okay, now think. Look at the diagram. Okay, tell me, where is the object going right now? O to A.
A.
Okay, not repeated, no repetition till now. Now it is going from where to where? A to O.
A to O.
Now it is going from where to where? O to
O to
B.
O to B.
Now it is going from where to where? B to O.
O.
Now what will it do? Tell me. Now it will go back to what again?
A.
Now it has started to repeat its motion or not? Now it
Yes,
has
sir.
because initially also it's started from where to where? O to A. Now also after one, okay, we call it one complete oscillation. See, going from here to here, back here to here, back here to here, and again from B to O. This is called one complete oscillation. Okay, and now the motion is going to be repeated. So now the time taken also, we can again tell you it is the time period again. Okay, this is how you count your oscillations again. Okay, so your pendulum, let's count the oscillation. See, if the pendulum starts from here, reaches this point, and again reaches now this point, right? Now when it reaches again this point, what will happen now, guys? Now it will repeat the initial motion or not? This is motion 1, this is motion 2. Okay. Now if it goes back down again, this is motion 3, right? But 3 is a repetition of which motion?
1.
1. Now the motion
One.
is repeated. Okay, so this is how you count your oscillations. So see, the moment the pendulum goes like this, okay, the moment the pendulum swings like this, no, from here to here and again reaches here, now we count 1. This is called one complete oscillation. Okay, if it does that again, 2 oscillations. Okay, but look at this, suppose, okay, if I just tell you it starts from here and reaches here, will I call it one oscillation or half oscillation, guys?
Half
This
oscillation.
is half oscillation.
oscillation.
Yeah, okay, this is 1 oscillation, 2 oscillation, 3 oscillation. Okay, I'm moving it too fast. Let's forget about this example now. Okay, I think you got the point. Okay, now apart from these terms that we need to use, we have one more important term, okay, in your oscillations, and that is your frequency. Check. Okay, frequency is again very important. Okay, check. The terms that we have already is time period. If I take the reverse, okay, or inverse of your time period, we get a quantity called what, guys? We call it frequency. I'll define to you both. Okay, check. Frequency and time period. Time period means what? It is the time taken for
One oscillation.
one complete motion. Okay, one complete periodic motion, or let's say oscillations. You are right. Okay, with oscillations also. Okay, this is how you define time period. Okay, time taken for one complete motion. But look at this, your frequency is time period or just the opposite? It is just the opposite. So look at the definition. Okay, don't forget, time taken for one complete oscillation is called time period. But look at this. Okay, the number of oscillations, look at this, frequency means number of what? Number of
Oscillation.
oscillations that you get in unit time, or let's say per second. Another name of unit in unit time means per second. Okay, so they're just opposite. Can you understand? Time taken for one complete motion is called time period. The amount of time, okay, let me speak like this, amount of time taken, right, for one complete oscillation is called time period, whereas the number of oscillations that we get in one unit time, or let's say per second. Okay, so do you understand? Here we are talking about one complete motion, here we are talking about 1 second. Okay, here we calculate in time period, we calculate the time taken for one complete motion. In frequency, it's like we are talking about how many complete motion we get in 1 second. Can you understand? They're just opposite or not?
Yes, sir.
Okay, did you realize? Okay, so let's check the units also. Okay, frequency will be having what kind of units, guys? It will have a unit of time or time inverse. Okay, I don't know why my screen is gone. 1 second, I will rejoining. Okay, so frequency, what is the unit, guys? Tell me, it is seconds or 1 by second?
Second.
1 by second.
1 by second or second inverse, yes. Okay, so yeah, obviously we have that. Second inverse is the unit of frequency. Second inverse, I think by now you already know. What is this called, guys? It is also called
Hertz.
hertz. Okay, so suppose somebody comes and tells you frequency is 10 hertz. What does it mean? It means I'm telling you how many oscillations are there.
10 oscillations.
10 oscillations, yes, 10 oscillations completed in how many seconds?
1 second.
In 1
1
second. That
second.
is the meaning of frequency 10 hertz. Imagine 10,000 oscillations. Okay, 10,000 oscillations in 1 second. 10,000 hertz is the frequency, right? Okay, can you imagine? You cannot even imagine actually, right? It's very fast, no? Okay,
Yes.
okay, imagine. Okay, you're playing swing, no? Your friend is here. Okay, this is the seat. Who is this? This is Biswadeep. Okay, and Rajdeep is pushing, no? I think, yeah. Okay, Rajdeep is pushing Biswadeep. Okay, imagine, okay, he goes back and forth, one oscillation completed, say, oops, wrong, once here, once here. How many oscillation completed? 1. Imagine he does that. Okay, Biswadeep does that how many times? 10,000 times in only 1 second, right? It's a very quick oscillation actually, right? Okay, so always remember, okay, if there are so many oscillations in 1 second, okay, What about your time period? It's going to be high or very, very low? If frequency is high, indirectly I'm telling you that time period is
Low.
low. Time
Low.
taken to oscillate is low. Okay, frequency very high means what? You are oscillating very fast. That means you're completing the oscillation very fast. That means the time taken by you will be low. Okay, so they are opposite. I think that way also you can understand how they are related. I think this part is clear. Okay, but I'm also going to bring one more thing. Okay, look at this. The next term after frequency. Okay, we have another frequency which we will be needing. Okay, and we call it angular frequency. It's totally on maths part. Okay, this angular frequency, but the idea is same. Okay. Don't forget your angular frequency is denoted by omega. That's what we are going to use, and omega represents this one. Check. I'm going to write 2 pi, and 2 pi everybody knows, right? What is 2 pi, guys? What does 2 pi represents? Angle or complete angle?
Degree.
Complete angle.
Complete
Complete
angle.
angle.
360 degree. 360 degrees. Just imagine. And 360 degrees should make sense to you. Okay. 360 degree means what? It's like one round, no?
One complete rotation.
One complete rotation is like taking one round. Okay, 720 degree also makes sense, right? It means how many round you have made? 2 rounds, 2 complete rounds. Okay, so 360, don't forget, it is like one complete round. So omega definition is not 360. Okay, it's 2 pi with one complete round, of course 360 degree, but you multiply with what? F. So this term becomes the angular frequency. I think you can understand how we are getting something like your angular frequency, right? You want to calculate angular frequency. What you do? You take the frequency which we call, I can call this frequency as linear frequency also. Okay, we call it linear frequency. That's one thing. Okay, equals to 2 pi into f. Okay, you take the 2 pi, the complete angle, multiply with f, you get angular frequency. Okay, now there's a reason why we need this angular frequency. Very, very important. Okay, and don't forget, what is the meaning of high angular frequency? Indirectly, high angular frequency means what? Large? Yes.
Frequency.
Large frequency. That means, again, okay, same thing. Physically, it means same, right? It means very large number of oscillations per second. Very quick oscillations per second. Time period will be low again. Okay, I can also write like this, see guys. I can also write 2 pi divided by what? Capital T, because your frequency can be replaced by 1 by T, no? So I can write angular frequency equals to 2 pi by T. That's how you calculate your angular frequency. Okay, later you will really understand, okay, why this omega is important for us. Okay, and now I think I'm ready, okay, to really go for your oscillatory motion properly, to discuss properly and check. Okay, this is now, everything will become very much mathematical now. Okay, so check, say I need help from your actually trigonometry. Okay, check. I'm going to use this axis, the graph. Oops. If you don't understand this graph, you really have to ask me. Okay, I will also show you why it is so important. Okay, say let's say this is angle. Okay, the x-axis, I'm taking it angle. Let me really bring that graph paper. I'm going to go slow, okay guys, because otherwise you will not understand again. Okay, so I'm going to go slowly. We are not worried about the exam. Okay, we are not working for the exam. We really want to learn this topic. Okay, that's our aim is. Okay, so say on the y-axis, I am going to put the sine of the angle. Okay, so I'm going to put here sine theta. This is theta angle, and I'm going to put sine of the angle theta. Okay, now look at my graph. Okay, and why I am drawing sine function here, it will be clear to you all. Just give me some time. Okay, this is angle axis, of course. On the right, that means I'm talking about more and more angle. That is quite all right. I told you I'm going to go slow, so let me really speak slowly. Say, okay, let's put some very nice angles. Okay, for which values we know. Say, let me start by writing pi by 2. Makes sense, right? Pi by 2. I think you know what is pi by 2, no?
90 degree.
90 degree. Yes. This is pi. This is 3 pi by 2. Okay. This is 2 pi. You can check. I'm increasing in the step of pi by 2, pi by 2, pi by 2. Okay. 90. This is like writing 90 degree. This is how many degree? 180 degree. 3 pi by 2 is like how many degree? 270 degree.
270.
Yes. This is 360. Like this, I'm increasing in the step of 90, 90, 90. Okay, with equal amount of deviations. Okay. So after 2 pi, I'm going to get what? Oops. Again another 90 degree. Pi by 2. How much will be that? 5 pi by 2. Then I'll get what? 3 pi. Then I'll get 7 pi by 2. Then I'll get 4 pi. 4 pi means 2 oscillations, 2 pi means 1 complete oscillation. Okay. Okay, let's really put the values of your sine theta now. Okay, so tell me, what is the angle here, guys?
0.
0. So if the angle is 0, theta is 0, that means, so how much is sine 0? That is 0.
Zero.
So our
Zero.
graph is going to start from here. Okay. And really, okay, you really need this graph. Very, very important graph. Very, very important graph. The sine function actually I'm trying to draw. Okay. Tell me, what will happen if I put an angle of pi by 2? I'll get how much? 1.
One.
Okay, let's say this is 1. Okay, 1. Okay. So when the angle, check, when the angle is 90 degree, when the angle is 90 degree, you can check the value of sine is how much? 1. Okay, so
1.
this is the point, right? Check, guys. All of you clear or not?
Yes, sir.
Okay. Now you tell me, how much is sine of pi? Equal to how much?
0.
0. Very good.
0.
Okay, so I'm going to come back to 0. So look at this point. What does it mean, guys, this point? When the angle is how much? Pi. Yeah, when the angle is pi, the value of sine of that angle is how much? 0.
0.
Okay, so this is what we have. Okay, then please tell me, what do I get after this? Which angle am I
Minus
talking
1.
about? Minus 1. Very good. Okay.
270.
270, yes. Okay, when the angle is 270 degree, okay, the value of sine is how much? Minus 1. Okay, so I'm going to plot that. Say minus 1 is 1 2 3 steps, so somewhere here minus 1. Okay, now you will really understand why am I drawing sine graph. Okay, I do not know. Those who don't know, you will really understand why we are drawing sine graph. Okay, again, tell me, guys, 360. 360 is like coming back to 0 or not?
Yes, sir.
So
Yes.
sine of
Yes,
sine
sir.
of 360 is the value is same as sine of 0. Okay, it is equal to 0. Okay, 0. So the graph is going to go back to 0. Okay, now let me really draw the intermediate points, which I did not show you, of course. Okay, we have intermediate angles here, which I did not take, of course, but we have those values. You have sine of 45 degree here. You can check this is how much, sine of maybe somewhere here 30 degree. So the graph is going to look like this. Okay, it looks like this. Okay, now who can tell me what does it look like?
Wave.
It looks like a wave.
Wave.
Very good. It looks like a wave. A sine graph actually looks like a wave. Now, some of you who did not understand why it looks like a wave, I'll tell you. Because a wave also has what and what? Crest and trough.
Trough.
Here also you can check. There's a crest and trough in this diagram also. Okay. Of course, we have them, no? So we have crest and trough. Again, we get what? In a wave, again we get crest. Again we get trough. It's a repetitive motion actually. Right? Wave motion is also a repetitive motion. Okay. So your sine function can do what? You know, your sine function, this graph that I'm drawing, can actually represent what? Your sine function can actually represent what?
A wave.
A wave,
Wave.
a repetitive motion. A sine function can really do that. Okay, so that's why we are going to use this sine function. Okay, but I really am going to talk in detail. Okay, please check. I'm going to drop all of this. I'm sure you're clear with this. I want to show you some effect of what will happen. Okay, if I continue plotting the graph, look what will happen. Okay, if I continue plotting the graph, oops, this will happen. Okay, check. Okay, why am I doing that? Let me just take this again. I'm going to get what, guys? I'm going to get here 1, I'm going to get here 0, I'm going to get here minus 1, again I'm going to get here 0. Okay, so my graph is going to look like this. So I'm going to get a repetitive motion like this, keep on going. Okay, no problem with that. Okay, but check now, this is not the important thing. This is the first graph. Let me just call it sine theta graph. I want to show you how does sine twice theta looks like. Is it okay? Are you clear, guys?
Yes, sir.
Okay, I'm going to draw directly. Okay, look, sine twice theta is going to look like this. I'm going to draw with green. Okay, or let me just draw in a new graph better, I think. Okay, I think let me just copy everything, copy and oops, paste. Okay, see, your sine twice theta is going to look like this. Okay, please check. See, it's going to rise till 1, go to minus 1. But look at this. Can you understand? Here, this is called one complete oscillation, right? Check. Yes or no? From here to here is called one complete oscillation because the angle there is 2 pi. 2 pi means one complete oscillation. Okay. Here, look at this. Do you understand that the angle, that the oscillation, right, or the whole complete cycle that I have is completed in pi or 2 pi?
Pi.
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 Okay, this is your not sine theta, by the way. This is not sine theta at all. This is sine theta or sine twice theta.
Sine twice
Twice.
theta.
Sine twice theta. That's how they are different. Okay, now if I continue, okay, it's going to just look the same. Say, go like that, go like that, go like that. Okay, it's going to go on going, keep on going like that. Now if I ask you, okay, how many wave do I have from here to here to here in the first graph? How many wave? 2, right? Check. 2 complete waves, right? Check, check, check.
Yes,
Yes,
sir.
Okay, we have 2 complete wave. But in the second diagram, okay, what do you think? I have 2 complete wave or 4 waves?
4.
1,
4.
2, 3 and 4.
4.
So what is the difference between sine theta and writing sine 2 theta? What do you think? They are same, or the sine 2 theta has double the frequency?
Double
It has
double
twice
frequency.
frequency. Yes, the twice the frequency of what? Of this graph. Can you say frequency means number of oscillations, right? It has 4 oscillations. It represents right now 4 oscillations. This represents only how many oscillations? 2 oscillations. So I hope you understand,
2.
right? What does the angle term does there, right? Is it okay?
yes, sir.
Okay, okay. I think you know what is the meaning of sine theta. You know what is the meaning of sine twice theta. You also know what is the meaning of sine thrice theta now. Okay, so the graphs are going to shift. Okay, the graph will become smaller and smaller if the angle becomes bigger and bigger. Okay, so that is one thing I wanted to show you just now. Okay, now you know what I'm going to do almost the same thing, but this time I am going to talk about the same thing, of course, but this time I will be talking about timings here. Okay, so please check. These timings are very, very important now for us. Okay, check. Those who are really not understanding can ask me. Okay, because I told you not a difficult, not a very easy topic at the beginning. Okay, it's going to take some time to get used to it. Students in class 11, they don't understand this topic. Okay, so if you are understanding, then you really have brain. Okay, so now check. See, okay, now see, if I am writing here 0, I want to change that axis now. Okay, instead of the calling it angle axis, I'm going to call it time axis. Is it okay? The first thing, this is going to record our timings, and let me just call this is as 1 second. Let's say this is 2 second mark, and this is 3 second mark. Okay, this is 4 second mark. All these are timings. Okay, and I can keep on going like that. That's not a problem. Okay, this y-axis I am going to record positions. Okay, I'm going to call it plus y, and I'm going to call it minus y. I'm going to show you what is the meaning of plus y and minus y here. Okay, please check. See, give me time. Okay, guys. See, I'm really going to speak slowly. Huh? So this is our pendulum. This is the support of the pendulum, and our pendulum is here right now. This is like position, let's say O. Okay, this is position O. Position O, of course. Okay, and from this, okay, if I go to the right, I have these options. Oops, what am I drawing? Let me just draw this one. I have 2 options. Okay, I can go to the right from position O. Oops, and I can go to the left of position O. Okay, so let me just show you that. See, okay, so this is position O. Till here I am calling it position Y. Okay, and okay, oh sorry, this is plus Y, this is minus Y. I think you can understand what do I mean by that. Is it okay, guys?
Yes.
Just check. Plus Y and minus Y. Did that make sense? Plus Y means I'm talking about right of position O. Minus Y means I'm talking about left of right of position Y. Okay. Oh, okay. So this is minus Y, that is plus Y. Check. Okay, these are distances. No, these are like 1 meter, 2 meter, 3 meter, 1 meter, 2 meter, 3 meter, 4 meter, minus 1 meter, minus 2, minus 3, minus 4. Okay, so this mark here, okay, I'm calling it plus A. I'll tell you what is that. And this mark here on the other side is going to be called minus A. It's like meters. Okay, let's say this is like 4 meters or 4 centimeters. This is an example. Minus 4 centimeter. This is like plus 4 centimeter. Okay, now look at this. Okay, our pendulum is here. See, the black one is the pendulum. Okay, this one. Okay, I'm going to tell you the time. Okay, and I'll tell you the position of this pendulum at those times. Okay, so now you tell me right now what is the time, guys. We are starting this this motion of this pendulum now. What is the time right now when you initially start? 0. So your time is 0 seconds. Okay, let me say 0 seconds. So 0. What is your position, guys? Do you have any distance from this position, or you have 0 position from this distance from this position? Where is the pendulum?
0 distance.
Okay, so what is your position, guys? I'm going to call it The value of y right now is how much? It is equal to not 1 centimeter, 2 if it is here, no, then I have to say how many centimeter, guys? 1
centimeter.
1 centimeter, but it's not there right now. The pendulum is here. Okay, so position is how much? Y equals to 0 centimeter. I think this makes sense, right? Check, guys.
Yes, sir.
All of you waiting.
Yes,
Yes, sir.
Okay, Aisha and all are still there. Aisha is there, yes, but Pringchi, I saw her, she left the meeting. What happened, Pringchi? Pringchi doesn't want to study this topic. Okay, now say. Okay, now let's start the motion. Okay, so let's say the pendulum is going to now oscillate. Okay, it's going to go to the right first. Let me say that it is going, it's going to the right. So the pendulum is going to rise and reach here, right? It has certain maximum position, right? It cannot go all the way to the right. Okay, so it has certain maximum position. Let's say it reaches till there. Okay, so now you tell me, is the pendulum moving? Yes. Where it is going? It is going from O to, let's say, A. Okay, and let's say it has taken 1 second, okay, to go there, right? So tell me, what is the time right now? What is the time?
1 second.
1 second.
1 second.
And what is the position? What is the value of y right now?
4 centimeter
4 centimeter, plus or minus?
plus.
In general, in general, I am going to use plus a. Okay, and we have a name for this. Okay, we call it amplitude. What is this called? Amplitude.
Amplitude.
The furthest you can go to the right or the left. Okay, we call it amplitude of the motion. Okay, so we have this right now. Okay, now you tell me. Okay, you really have to tell me properly, huh? When the pendulum is rising up and up and up, what do you think? It's gaining velocity or losing velocity?
Losing velocity.
Losing.
Okay, so when the pendulum is going from O to which point? Which point? A, right?
A.
It is accelerating or deaccelerating?
Deaccelerating.
Deaccelerating. Okay, fine. Okay, that's correct. Okay, that means losing right now. Losing velocity. I think this part is clear, right? Okay, we will talk about that also. Okay, now tell me what will happen, guys. Okay, it started from O. Now the object is going from O to A. Now the object will go from where to where, guys? We know the pendulum will go back to what? From A to O. A to O.
O.
How much time do you think is going to take?
1 second.
1 second, because if it takes 1 second to rise till A, it will take 1 second to fall. Okay, it cannot take 1 second to rise and 10 seconds to fall. Okay, because gravity is not going to allow that. Okay, so time is 1 second. Now your position is what, guys? What do you think?
O.
4 or 0?
0.
0 centimeter. Okay, you are back to this position. Okay, so you have gone to the right of O. Now you are back, reaching back to O. Okay, and now you tell me what will happen now. Next, the motion will be, it will go from O to another point called what? B.
B.
Okay, and the point B is where? It is on the left or right?
Left.
On the left. Okay, so it will reach, okay, on the left. Okay, and that is represented by minus A, or let's say minus 4 centimeter. No, so again the timing, let me just write it down. Okay, 1 second. Okay, so now your value of y is how much? Minus 4 centimeter in this example, of course, but it is equal to how much? General minus A. It is also amplitude on the other side. Okay, now the pendulum has reached here. See, the pendulum has climbed up here, and while it was, oh, I forgot to tell you, while the pendulum was going from A to O, right, down from A to O, you can check. From A to O, okay, I'm talking about going from here to here. What is happening to the pendulum, guys? What do you think? It is increasing in velocity or decreasing in velocity?
Increasing.
Increasing. Velocity increases, huh? Increases in velocity. Yeah, so that also we have to keep track. Okay, then it reaches a point called what? B. What happens here, guys? What is the velocity here?
0.
0. Agree, right? Because the object will keep on going, or it has to stop here.
To stop.
It has to stop,
Has to stop.
and then it is going to change the direction. Okay, you cannot change your direction, okay, without stopping. Try that. Okay, without stopping, can you change the direction, guys? Or reverse your direction? No chance at all. Okay, without stopping you cannot change or reverse your direction. Okay, so you are going to stop at these points, which are called amplitude. So always remember, whenever the object is oscillating at its amplitudes, the velocity is going to be how much, guys? 0. Acceleration is not 0. Okay, acceleration, I will tell you, acceleration or deacceleration, whatever it is going to be maximum. Okay, so if I ask you, okay, while going up, okay, does the object loses velocity here or not, guys? Tell me. Let me just ask you, somewhere here, does the object or the pendulum loses velocity or not?
Yes, sir.
Yes, sir.
Yes, but the pendulum loses most of its velocities here. Can you understand? The object loses most of its velocity up there. Okay, it's going very much up against the gravity. No, it loses most of its velocity here. That means, what do you think? There's acceleration or maximum acceleration there, or deceleration?
Maximum deceleration.
Yes, exactly. Okay, and when it falls also, right, the object loses or gains velocity?
Gains velocity.
But
Gains
but
velocity.
but again, same thing. It gains velocity here also, it gains velocity here also, but where does it gain the maximum velocity? Here. Can you understand?
Yes.
Okay, it becomes maximum later, of course, the velocity, but the rate at which the velocity is gained is maximum here. This is the place where you will notice the change of velocity is the fastest. Okay, whether it is an increase or decrease. Okay, in the amplitudes. Okay, not in the mean position. Okay, by the way, I forgot to tell you, this position is called what position? Mean position. Okay,
Mean
when you go
position.
to the right or the left, that point, right, respective to which you go right or left, okay, that point is called mean position. Okay, so that is what we have. Then please check. Okay, see, I was about to say something. Yeah, okay, where's the object going now, guys? From O to B. Done. Now it goes from where to where? B to O.
O.
Is going down right now, you know. Again, it takes how much time?
1 second.
Again 1 second. So now the value of y becomes how much again? 0 centimeters. So it has
Zero.
reached back to the original position. Okay, now tell me what will happen, guys. Again the object will go from where to where? The pendulum. O to
0 to A.
O2A.
O to A. Okay, now do you agree that the motion is repeated or not?
Yes, sir.
Okay,
Yes, sir.
okay, now please check. Okay, what am I going to do here? I am going to draw this is a graph showing what and what? Position and time. Okay, check. Okay, let me start. Tell me 0. When the time is 0, what is the position of our pendulum in our example?
0.
0. Very
Zero.
good. Okay, look at this. Time is 0, position is also 0. So this is the point I'm starting. See. Okay, fine. Time is 1 second. Where is the object? Oh, sorry. Oh, yeah, 1 second. Yeah. How much? Where is the object?
4 centimeters.
4 centimeter. That means my graph should have 1, 2, 3, and 4 plus 4 centimeter, right? This one is plus 4 centimeter. 1, 2, 3, 4. I will have minus 4 centimeter. So 1 second later, the object is going to be here. Do you agree with the graph? Just check. Yes?
Yes, sir.
Okay.
Yes, sir.
2 seconds later, that means another 1 second later, where will the object be?
0.
At 0. Another 1 second later, see, another 1 second later, right? The object will be in 0 position, okay? So the object is going to go back to this point here. Do you understand this represents y equal to 0 or not?
Yes, sir.
Sir.
Okay, now tell
Yes,
me,
sir.
where will be the object after another 1 second here, say? After another 1 second, it goes from O to B, no? So it will be in A or minus A?
Minus A.
Minus A. That means after another second, it reaches here, okay? This is the point, okay? Another 1 second later, we know it's going to go down back and it will reach point O again, okay? So it goes back there, okay? So 4 seconds later, it has reached there, okay? So now check, okay? My graph is not going to be like this. This is wrong. Anybody who can tell me why this is wrong? Who can tell me?
So because they are intermediate values.
Okay, but why not? Why it cannot be a straight line? Why it is not a? Who can tell me why it's not a straight line? Okay, tell me. Okay, what is the meaning of straight line if I draw like this? What does it mean? Who can tell me? This is
It
a,
is constant.
what is constant here? If I write like this,
Acceleration.
The rise is constant.
Velocity.
If I draw a
Velocity.
graph like this, it's a position time graph. What is constant?
Velocity.
Velocity.
But we know something, right? Is the velocity of this object going to be constant or not constant?
Not constant.
Not
Not constant, because acceleration due to gravity will not allow its velocity to be constant. That means that there will be a change of velocity, right? Okay, because of which it cannot be a straight line graph. Okay, and the graph that we get is something like this. I'll tell you. Now, can you understand? Initially, what is happening? The velocity is rising, but later what happens? Look at this. What happens here? Can you understand what I'm trying to say? What is happening here? What
It
is this? What is this? What is this line that I've drawn there? Alright. If I draw a curve and I draw a line like that, what is this line called?
Tangent.
Tangent. Another name is?
Tangent.
Another name is?
Slope.
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 Do you agree with me right now? The slope is what of this one right now? At this point,
Slope is 0.
slope is 0. Very good. And you know, right? What is the meaning of slope 0? Slope is
Acceleration
slope is 0 means velocity is
velocity 0.
0. Do you agree or not that the velocity at that position here, right here? Look at this. Here, the velocity is how much? 0. The
Zero.
slope, that means the slope should be 0. And that's why the graph, okay, is going to take such a shape. Look at this. It's going to take such a shape like that. And like this and like this. Can you understand now what am I trying to draw here? I think I should not talk more than this. But this is what is going to represent here. What kind of motion? What kind of motion is this, guys? First tell me, does it represent repetitive motion or not?
Yes, sir.
Yes,
sir.
yes, it represents
Yes, sir.
repetitive motion because same thing is going to happen again and again. Okay, so it's a repetitive motion. The slopes, they tell you what in this graph? Velocity, right? The slopes will tell you
Velocity.
velocity. Yes,
Velocity.
okay. What kind of slope will I get here, guys? Check. Exactly here. Slope or very high slope?
Very high.
Very high slope. That
Very high
means
slope.
indicating here, right? The velocity will be velocity will be high or it will be maximum actually.
Maximum.
Maximum.
Maximum velocity. Okay, here the velocity will be maximum and here the velocity will be equal to 0. Okay, we know that. Okay, that's going to happen, right? Okay, now let me ask you, okay, what kind of slope we have here? Positive or negative slope?
Negative.
Negative slope.
Negative.
I think you can understand what does it mean. Here we are going to have negative slope. That means velocity is
Negative.
negative. That means you are going to the left or the right?
Left.
Going to the left. So see, these graphs are so nice, no? They tell you all those things. Okay, okay, done. I'm done right now. Let's check here also a bit. Okay, what is this, guys? Positive or negative slope?
Positive.
Positive.
Slope.
That means
Positive.
that means between 3 and 4 seconds, the object is going to the left or the right.
Right.
To the right.
Yes, to the right. Okay, and I can show you how it happens. See, okay, the motion was like this. Okay, the object starts from O, goes to what, guys? In 1 second, A, then it goes to B, then it goes to O again, then it goes to what? A, right? Did I make sense? No. From A it goes to O, then it goes to what? B, then it goes to
O.
O again. Okay, so going from O to A to O, like that, like that. Okay, this is how timings are distributed here. Okay, I think you got the point. What I'm trying to say. Is it okay, guys?
Yes, sir.
Okay, now
Yes,
comes the best part. Please tell me. Is this a graph? Yes, it's a graph. Yes, it's not a straight line. Every straight line will have an equation, right? Y equals to something something x, right? But here will I write y equals to a function of position or I'll write y is a function of time?
Function of time.
Function of
Okay,
time.
yeah, we can write y depends on x, of course. This is y coordinate and this is not x, but we are going to call it time coordinate. That means your y depends on time, and you'll agree with me. The position depends on time or not? Yes, position depends on time. That means your position y is a function of what? It's a function of time. This makes sense, right? Just check.
Yes, sir.
Okay, all of you make sense or not?
Yes, sir.
Okay,
Yes.
I'm going to write something now. Okay, after this 4 seconds, one more thing, I just want to write it down. Okay, I told you, okay, this is going to become a bit complicated because of maths only. Okay, but don't worry, you may understand what I'm trying to do here. Next thing, say, okay, now you tell me, when I draw a graph which looks like this, right, what will happen? Okay, check. Do you understand that this position and this position are different or same?
Same.
Okay, this like the object has reached A, this is also like the object has reached A, right? This one means the object is at A. This also means the object is where? At A here, okay? Right. Okay, now check, okay. Do you agree with this? Please check. The position of the object at what time? 1 second is same as the position of the object after 1 plus 4 seconds or not? Please check.
Yes, sir. Yes, sir.
Because this will represent how many seconds? This will represent 5 seconds. And what is this? This is what time? The position when the time is 1 second is same as the position is when the time is
5 seconds.
5 seconds. So I am writing like that. Okay, now I will tell you properly what does it mean. See, that means position when the time is t is same as position when the time is t plus capital T, because capital T is the time period, right? Check.
Yes, sir.
I'll give another example. The position of the object after 2 seconds, right, will be same as position of the object after how many seconds?
6 seconds.
2 seconds plus
4.
plus 4 seconds. Why did I say that? Because after 4 seconds I know the cycle will be again repeated or not.
Yes, sir.
So whatever is your position is f at 2 seconds, you'll have same position after how much time? 2 plus
4 seconds.
plus 4 seconds. Okay, so this is what is exactly happening. Okay, now I'm going to ask you. Okay, you already have told me, right, y depends on t, but can I write like this? Y equals to, let's say, m into t. Is this correct or wrong? If I want to tell you this is the equation of the graph, is this correct equation or wrong equation? Y depends on time, but is this correct or wrong? This one, this equation. Check.
Wrong equation.
Wrong equation. Tell me why? Because this equation cannot represent what? This motion, right? This equation means
Yes.
what? When the time increases, y also increases. So y equals to mt. No, y equals to mt represent this kind of graph. See, can you understand? Y equals to mt is this graph. So this is definitely not that graph. So y equals to mt is not the equation. Okay, but do you agree with me that our sine function, which I've already drawn before, right, can come and help us write the equation of your position and dependence on time or not? Can you understand now? Yes or no? Check. So now I'm going to write. Okay, tell me, y is a function of what? Let me write slowly. Y is a function of time. That is correct. Y depends on time. Y does not depend on time like this. This is wrong. Y does not depend on time like this. Mt square. This is also wrong. Okay, how does y depends on time? Through what function? Quadratic function or a sine function?
Same function.
Wow.
Sine
The
function.
position is behaving like what kind of function? Like a sine function. It goes up and down, okay, in this fashion, right? So sine function, okay. But I cannot write here t. This is wrong. Who can tell me why this is wrong? Not complete. See, I'm talking in detail. I told you, okay. I cannot go rush and then finish this topic, okay, because I really need to form a little bit concept at least for you, no? So tell me why this cannot be the equation. Why this cannot be the equation? Something is wrong here. Any genius student who can tell me? Yes. Why this cannot be the equation? Are think a bit. What is this?
Time.
Time? Yes, time. It can represent any of the time. 1 second, 2 second, 3 second, 4 second, any time. What is this?
Position.
Position.
Okay, yeah. Position depends on time, but of course through sine function. Okay, but we know something about sine, right? Can I put time inside sine, or I cannot put time inside sine?
Cannot.
Cannot put. What can we put inside sine? What can I put inside sine?
Angle.
Angle. You cannot put time. Okay, so this is wrong. This is not complete. Okay, so look at the adjustment, and this adjustment will I think will make sure that you have really understood everything. Okay, look at this. I'm going to write here omega t. Did you understand what I wrote, guys? What I wrote? Omega t. Okay, now I need to show you something. Okay, look at this. Omega into t. What is omega t? Let me show you. Okay, what is omega t? What is omega? First tell me that. 2 pi into what? F. Right? T, let me write t again. Let me write again. Okay, 2 pi by capital T into small t, right? This is your omega t or not? Don't worry, you'll get me. Okay, just give me some time. My pen is not writing. What happened? Battery over. Battery is 0%. I have to wait now. Okay, now please tell me, what is the unit of omega t? Is it angle, time, or it is just angle? There is another reason, okay, why I'm writing omega also. I will just show you very quickly, okay, but don't worry. But just tell me, what is omega t units? Yes. Angle, because omega is has frequency is 1 by time. Okay, so time and time units will get cancelled. The only thing remaining there is 2 pi, and 2 pi represents an angle. Okay, so omega t makes sense inside this sine function. Do you understand? First of all, I think you are clear.
Yes, sir.
I think you are clear why I just cannot
Yes, sir.
keep. I think you are clear why we just cannot keep t. Okay. Second thing, it also should make sense to you why omega is important inside. Can you tell me why omega is inside? If you can just tell me that, I'll be very happy. Why am I keeping the omega inside sine function? If, okay, if this pendulum, okay, think, okay, if this pendulum, instead of completing in 4 seconds, right, it's completing the whole oscillation in 4 seconds. If this completes in 2 seconds, okay, tell me, what will happen? Will I get this graph, or I'll get a smaller graph, or a shorter graph, or a faster graph?
Graph.
I'll get a graph, okay, look at this. I'll get a graph which looks like this. Do you agree with this? Yes or no, guys?
Yes.
Did you understand all of it?
Yes, sir.
I'll get a graph which looks like this. Check again, okay? This one. Okay, what does it mean? Is it the same pendulum, or this a pendulum oscillates much faster? The green pendulum,
faster.
the green pendulum is taking how much time to complete oscillation? 4 seconds. But this pendulum is taking how many seconds to complete the oscillation?
2 seconds.
2 seconds.
2 seconds. And where do you put this frequency thing? You should put this frequency inside here or not?
2 seconds.
Yes or no? The red one, right, represents frequency or higher frequency? The red one, the smaller graph.
Higher frequency.
Higher frequency.
Higher
And I just showed you earlier what's the difference between sine theta and sine twice theta. What is the difference? The difference is what? They have different frequency or same frequency?
Different.
The frequency of this is greater than that, and that's why, you know what, this omega should always enter inside what? Inside what? Which function? Sine function. It will help you a lot. Okay, that not help you, but it will exactly do whatever it has to do. Okay, don't worry, you will get everything. Okay, don't worry. Till now I think it's clear. At least you are clear why omega should be there. At least you're clear why it's t should be there. Till now, if you are not so clear, I'll just tell you what is y. Please tell me, guys, what is y first of all?
Position.
Is it just position, or is it position at any time?
Position at any time.
Position at any time. At any time. And that time is what? Time is t. Example I can tell you. Okay, look at this. Example I can tell you. At t equal to 1 second, tell me directly without looking anything. That's the graph for this one. Okay, tell me what's the position? Plus 4.
A.
Plus a, plus 4 centimeter. Do you understand what is y and t now? T represents this one, any time, and y represents the corresponding position at that time. Okay, so we are writing the equation for that actually. That's how you draw the graph. No, that's what we are doing right now. Don't worry, you will understand. Okay, just give me one more second. Okay, one more idea and you will understand. Okay, now there is one more problem. Okay, if I write like this, the equation, right, every graph has an equation, I told you. If I write like this, what is in front of sine, guys? What is present? What is present here? If I don't write anything,
1.
1. It means the graph is going to how much? The graph is going to rise, no? How much? 1 and fall to minus 1. Do you understand? If I write like this,
1.
okay. If I write here 2, if I write here 2, the graph will rise up to how much?
Plus 2.
Plus 2 and fall to plus minus 2. Can you understand, guys, the difference in writing sine theta and writing twice sine theta? Do you understand the difference between them, guys? What is the difference? Sine theta will rise up to how much? 1. Twice sine theta will rise up to how much?
2.
2. Okay, now look at the graph and tell me. Do you want the in this graph, right? This graph is rising to 1 or up to 4?
4.
The graph is rising up to 4. So now you tell me, okay, y equals to sine omega t. Is it correct or still wrong?
Wrong.
Wrong. This equation cannot represent this graph because our graph is rising up to how much? 4. That's why what should I write here in front?
4.
4. Now it is very much correct. I will show you right now that this is what, guys, very much correct. This is what represents this entire curve. Okay, I can show you right now. Okay, now you tell me whether it makes sense or not. Okay, please check. So I am writing y equals to what? 4 sine omega t. Let's be clear what are the things I'm writing here. Please tell me what is this called? 4, right? What is this for?
Amplitude.
Amplitude. Okay, amplitude is always written there. Yes, okay. What is this omega? Let's be clear. Angular
Angle.
Angular frequency.
Angular-
Okay, this is the equation. I'm repeating again. This equation represents what? The motion of this pendulum right now. Okay, oops, the book also is flying from my decks. Okay, now check. See, so check now, and let me rub everything. Don't worry. If you do not understand anything, no problem. Okay, you're still fine. Okay, you're still fine. I'm just going to write now the equation again. Y equals to 4 sine omega t. Okay, let me just fill up the other things also. 4 sine omega is how much? 2 pi by capital T small t. Let me just fill up again. Y equals to 4 sine 2 pi divided by, how much is capital T for us guys? Capital T is very fixed, no? How many seconds? 4 seconds. So I'm going to write here 4. See, I'm going to write here 4. Okay. Now we are ready because this equation has every information that I need to calculate the position at a given time. Okay. Now, by looking at the graph, tell me what is the position after 5 seconds? Looking at the graph.
4.
By looking at the graph at 5 seconds. At 5 seconds, what is the position?
4 centimeters.
Y equals to plus 4 centimeter. Agree all of you? Check.
Yes,
Yes
sir.
or no? Okay, now I'm going to show you the same thing but without looking at the graph, but by looking at the equation. Okay, so now tell me, please tell me, at a time of how many seconds I want to calculate the position? At a time of 5 seconds. Okay, so I'm going to take this time and put it back here for our pendulum. Okay, so let's check what will I get. Y equals to, help me out, 4 centimeter. Don't forget this was amplitude, centimeters, right? Then I'm going to write here sine, waiting, 2 pi by 4, and what should I write here? 5.
5.
Okay, and you know what, I can just cancel 2 and this 4. I'm going to get 2, right? So I'm going to get how much now? Tell me. Y equals to 4 centimeter sine of how much? 5 pi by 2. Okay, now do you agree with me? Sine of 2 pi plus pi by 2, this itself is nothing but what? Sine of what? Pi by 2, right?
Yes, sir.
Okay,
Yes,
sine
sir.
of 2 pi means what? It's like you're back to what? 0, right? So this is like sine of pi by 2 and equals to what? Sine of pi by 2, both are equal to 1, right?
Yes, sir.
Okay, so sine
Yes,
of
sir.
5 by 2, that's what I want to say. Sine of 5 by 2, the value is exactly equal to how much? 1. So when I multiply these two now, okay, what do I get? I get y equals to how many centimeter?
4 centimeter.
4 centimeter. Are you clear with this, guys? Just check. So,
Yes, sir.
so using this equation, what did I find out? Or what can I find out? The position of the object at what
The
time?
position.
At any
Any
time.
Any
But provided it is any motion or it has to be an oscillatory motion.
Oscillatory
It has
motion.
to be oscillatory motion. Plus, provided what I have to know about the motion. I have to know what? Amplitude of the motion. Yes, and you also have to know what? What is this?
Time period.
Time period of the motion, or at least frequency you have to know. Can you understand? So I'm going to write again back. Okay, see, like this you can apply to other cases also. I'm not going to go into detail. I don't think so I should do that anymore. So please tell me, guys. Okay, how do you represent object going back and forth? You write position equals to function of what? Time. That's the first thing.
Time.
The position at any time will be equal to what? Position at a time plus what?
Time period.
Capital
Time
T.
period.
Okay, that is also equal to y. T plus what? Twice T, agree, right? Check. After 2 time periods also same position, right?
Yes, sir.
Okay, that means I
Yes,
have a
sir.
general formula. You know what? Y of T is equal to what? Y of T plus NT, capital, can you understand this one? So if they ask
Yes.
you, what is this? What is this? What is the answer? This shows that it is what kind of motion?
Periodic.
Periodic motion, or also of course it can also represent oscillatory motion. That's the first thing. Okay, now if a pendulum is going to start from 0, or any object starts from 0 and goes to the right, what will be the equation? Please tell me. Waiting. Amplitude sine omega T.
Omega T.
Is it okay, guys? What is this called? It has a name, by the way. What is this called? Position time relation. Okay, this is what? This is position time relation. Let me again remind you. If omega is large, can you visualize what is going to happen? If omega is large, okay, you know, by the way, what is omega also, huh? Omega is 2 pi into f, that is like writing 2 pi by capital T, okay, and of course A represents amplitude. I think you're clear with this. Can you visualize now if I tell you what is the meaning of high omega? All of you, yes, visualize.
The graph will be shorter.
The what will be shorter?
So like the frequency will be high, so the graph will be.
The graph will be shorter. That means frequency high. Just imagine frequency high. That means the object is going back and forth very fast, like that. See, very fast. It goes back and forth, very fast. Can you understand? That's the meaning of very high value of frequency or very high value of omega. Okay. Please visualize like that. Okay. What is the meaning of A very high, guys? Tell me. Amplitude. A represents amplitude.
The
It
graph
means
will rise up.
The
very
graph will rise very high.
graph
and
will
fall
rise very
low.
up high like that. Okay. But indirectly, what does it mean? That means the object is very close to the mean position or going very far from the mean position.
Very far.
That's how you represent. That's how you look into this equations. Can you understand? So if I write like this, now see, if I write y equals to 5.0 centimeter, okay, and then I write sine of, let's say 100 pi t. Can you tell me now? Can you compare and tell me? Is this a periodic motion? Yes. Is it an oscillatory motion? Yes. What is the amplitude of this motion, guys? 5 centimeter. Very good. Plus minus is going to be on both sides. Yes. What is the omega value here?
100.
100 or 100 pi?
100 pi.
100 pi.
Omega is 100 pi. Okay. Now tell me, can I find frequency or not?
Yes, sir.
Yes. Because in place of omega, what can I write? 2 pi.
2 pi
F equals to how much? 100
pi.
pi. Pi gets cancelled. So frequency will be 100 or 50 hertz.
50 hertz.
50 hertz. Yes. Can I find the time period? Yes. You can write 1 by f and you can write 1 by 50. That is like how much? 0.2 or 0.2. I don't know. 0.2 or 0.02?
0.02.
0.02. Okay. So did you understand, guys, that once I give you this equation, I give you all the information about how the motion of the object is taking place. Is it okay? Did I make sense?
Yes, sir.
Okay. This tells
Yes,
you
sir.
how much this object is going to the left and the right. This tells you how fast is the object going to the left and the right. Yes or no? Now I think you are all smart. Okay. You understood what I'm trying to say. Is it okay, guys, all of you?
Yes, sir.
Anyone who didn't understand, because I need the time. I need 1 minute break, 10 seconds break actually. Okay. In that break, you are going to answer me. Okay. Yes. I'm asking you. Did you understand? That's what I'm asking you. Please answer me in that 10 seconds. Hurry up. Switch on your mic, guys. Don't be lazy.
Yes, sir.
Yes,
Okay. Okay. All of you understood. Very good. Very good.
Yes, sir.
Okay. Very good. Okay. If you have really understood that. Okay. But I need to bring one more thing. Okay. Now check. That's it. Okay. I'll do just one more thing. Then I'll stop for today. Okay. Yeah. Please check. Now what is this? Okay. Check. Check. Okay. Try to correlate and tell me. Okay. You have to really tell me, huh? What is going on here? See. Oops. Okay. See. 1 second, okay. Okay, see, you tell me it makes sense or not. Okay, see, this is 1 second mark, 2 second mark, 3 second mark, 4 second mark, 5 second mark, 6 second mark. Okay, this is plus y, minus y, this is 0 meters, this is time axis again. All these are in seconds. Okay, check. Okay, look at my graph now. Okay, it is suppose say plus 10 centimeters. 1 2 3 4 1 2 3 4. Okay, this is minus 10 centimeters. Okay, look at the graph now. Okay, see, let's check now whether you have brain or not. Okay, see. Okay, the graph goes down like that, then it goes like that, then it goes like that, and then another 7. No, this one 7, this is 8. Okay, so it goes like this. Okay, now tell me, look at the diagram and tell me, okay, what kind of motion it represents again. Is it an oscillatory motion or not?
Yes.
Is it an oscillatory motion, guys? Tell me. Who can tell
Yes,
me?
sir.
Okay, because if I
Yes, sir.
continue, okay, let me just continue this whole thing, okay? This whole thing, oops. My pen is again not working. I should have charged it, no? It's not even showing 0 now. Now it's showing. 1 second. Actually, what I want to show you right now is, again, I'm going to copy and continue this blue curve, okay? So it's going to go to the right. So it is going to be repetitive motion. Can you realize, guys, it is a repetitive motion or not?
Yes, sir.
Okay, where is the
Yes,
object
yes, sir.
starting? Can you tell me where is the object starting? Is it starting from the mean position, or is starting from the extreme position?
Extreme.
It's
Extreme
starting
position.
from plus 10 position. Okay, then where it is going, guys? It's going to the right or the left?
To the left.
Towards Left.
It is starting from extreme right, then it's going to 0, right? In how many seconds it reaches 0?
2 seconds.
2 seconds it reaches 0. After that, reaching 0 in 2 seconds, it is going to the left or the right still?
Left.
It is going to the left still. That's why it will reach where? Minus 10, right? Okay, you can check the tangent there. It is negative or positive? The slope negative, no? Check.
Yes, sir.
Okay, then in 4 seconds, where it has reached, guys? Tell me. In 4 seconds.
Minus 10.
So it is left or extreme left?
Extreme left.
Extreme left. In 6 seconds, again it reaches
0.
yeah, mean position 0. That means between 4 and 6 seconds. Okay, between 4 and 6 seconds, where it is moving, to the right or left?
Right.
To the right. Very good. To the right. Again, between 6 and 8 seconds, it is moving
Right.
to the right. Very good. Yes. Okay, I think you are really understood. Okay, others I don't know.
Also,
Yes, tell me.
velocity increases from 4 to 6 seconds.
Velocity increases from 4 to 6 seconds. Let's check. Tell me, what is the meaning of this? Where are you? Where is the pendulum? Here. What is the meaning? Where is the pendulum? Let's draw that, no? Oops, wrong pendulum. Where is the pendulum? Tell me. Here. At 4 seconds.
Extreme left.
Extreme left, right? Check. So between 4 and 6 seconds, right? The pendulum will reach here, no? After that, this is the motion, right?
Yes.
Between 4 to 4 seconds
sir.
and 6 seconds. Okay. Yes. So now tell me, the pendulum is going up or going down? Against or along gravity? Going
Along
down.
with the
Along gravity. Okay. So now you tell me, it's going to increase in velocity or decrease in velocity?
Increase.
You got your answer. Okay. And the velocity, do you agree? Here there will be maximum or not? What is maximum here?
Velocity.
Velocity will be maximum. And what is the meaning of maximum velocity? Your acceleration will be how much? 0. Let's not write g equal to 0, but the acceleration of the object will be equal to?
0.
Because you are already so down there, right? So you cannot be accelerated. Do you agree? No?
Yes.
You are
Yes,
on
sir.
Earth, okay?
Yes, sir.
You are on the surface of Earth. Okay, how much acceleration you have? 0. You don't go up, you don't go down. Of course, g is acting on you, okay? But suppose if you go top of a building, no? And then, then you can go down, no? You will really see the acceleration, okay? But right now, what is your g? Acceleration is 0, okay? I'm not going to talk about that right now. Done. But let me copy this one and again, okay? I was about to ask you something, okay? So this is a repetitive motion. I'm just doing that. So now you tell me, okay? Here also, y depends on time or not? This is time axis. Y depends on time. Correct, right?
Yes, sir.
Okay. What is the time period in this graph? Please identify how much is the time period. Going down from here to here, right? And here also it goes down from here to here. So how much is the time period?
8 seconds.
8 seconds later, the repetitive motion is repeated. See, like that. Do you understand? So time period is 8 seconds. Okay, let's find frequency also. How much is the frequency? 1 by 8 hertz. This is the frequency. Agree, right? Check, guys.
Yes, sir.
Okay, let's find omega also.
Yes,
Omega
sir.
is how much? 2 pi into f. That is like 2 pi into 8. No. 2 pi 1 by 8. Okay, we know omega also. That is equal to how much? Pi by 4, right? Check. Pi by
Yes, sir.
pi by 4. Correct, right? All of you check.
Yes, sir.
Okay, I want to ask you one thing now. Okay. Oh, my ears are paining with the headphone. Anybody has good headphones? Please donate to your teacher, poor teacher. My headphone is really hurting my ears. Okay, Somitra has a very good headset, no? I heard at home. You bring, okay. Look, he's quiet now. Okay, see. I was saying something, okay. Please tell me, okay, will the equation looks like this or not? Now check. Y equals to, okay. What is the amplitude? First of all, identify amplitude also.
10.
10.
10.
Okay, 10 centimeter, correct. Okay. So, yeah. What will be the equation? Equation is A sine omega t, right? But this will not help us this time. Why? Because our sine graph starts from what? 0. Our sine graph starts from 0. Have you noticed that? Every sine graph, okay, is going to start from what? 0, like that, no? Okay. But this graph, do you think it starts from 0 or it starts from maximum?
Starts from
Starts from maximum. So always
Maximum.
remember, okay, whenever a graph starts from maximum, right, you can imagine as if it is a sine function or cosine function.
Cosine.
Cosine
Cosine
function, okay,
function.
yes. So my equation is going to look like this. Y equals to amplitude, no problem with that. But I have to write what, guys, now? Cos of what?
Cos omega t.
Cos omega t. Exactly same, but sine should be changed to cos. If you still want to use sine, I'll tell you how to use it. Sine, see. Y equals to A sine omega t plus pi by 2. Do you understand this? Okay, or
Yes, sir.
let me not ask you that, but let me ask you, do you understand this one first of all?
Yes, sir.
Okay, this is exactly a
sir.
shape of which graph? Not sine graph. This is a shape of cosine graph. Okay, but guys, did you understand this one? If you have understood this also, I'll be very happy. What is this? I do not know whether you have learned this or not, but sine of theta plus pi by 2, how much is that equal to?
Cos theta.
cos theta.
Cos theta. So writing like this also, it means what? You're talking about cos theta. This will it start from 0 or it will start from 1? What do you think, this one?
So 1.
It will start from, because it's exactly like cos. It is going to start from 1. Okay, you don't believe me, I can show you. See, let's put sine of 0, 0. Okay, sine of 0 plus pi by 2. How much is the answer? Sine of pi by 2, 1, right? Okay, so that means sine of this function, right, will start from what? 1. When the angle is 0, it will start from 1. Okay, but if there was no pi by 2, then of course it will start from 0. Okay, but no, don't worry. I just wanted to bring this because if I write an equation like this, okay, automatically, okay, this extra angle, do you see this pi by 2 I have written here, right? Can you see this pi by 2?
Yes, sir.
This is called phase. What do we call it? Phase. At this point, I don't want to extend this idea of phase right now. Not so important. Just remember the symbol is phi, okay, and that is what we call it as phase. This actually tells you, okay, where are you starting from. Example I'll give you. Say, if I write y equals to a sine omega t, tell me what is the phase?
0.
Plus 0, right? Check all of you guys. What is the phase? This extra angle after omega t, if I write, that is called phase, no? So what is the phase right now? 0. Okay, what does it indicate? You know, it indicates that the motion of the object starts exactly like what? Exactly like which function?
Sine function.
Sine function. If I write y equals to a sine omega t plus pi by 2, now you tell me, what is the phase right now?
Pi by 2.
Pi by 2. Pi by 2. That means you tell me, the motion of the object starts like a sine function or cosine function?
Cosine function.
Cosine function.
function.
Okay, so this angle is called phase, and that is what it does. Okay, so for today I will tell you. Okay, we will just stop here right now. We will not do more than this for today. Okay, it's fine, totally all right. Tomorrow, not tomorrow. Wait a minute. Tomorrow you are coming only, no? Tomorrow is what day? Tomorrow is Thursday, na? Tomorrow Thursday. Oh, you already have no tuition tomorrow? Yes. Tomorrow you have only, no? So we will continue this one only, right?
Yes, sir.
Okay,
Yes, sir.
we will continue this chapter only, okay, because Aisha and also they need, okay. So Aisha, I don't know, is joining or not. I do not know, okay, whether they need these topics or not, because Aisha, these topics your school is doing, these ones, or they are just doing some important ones.
So they finished.
Yeah, they finished means they exactly did these topics, or they just left these topics and they did or not. What remember?
So
No, I mean to say, I'm asking you, did they do these topics?
yes, so they did.
They did, no? Okay, fine. So I'm also doing. Okay, fine. Then other schools, so I do not know what is happening. Okay, in Elishaba school, okay, what is going on? Can you tell me? What are they doing? Have they started?
So they're doing thermodynamics right now.
Thermodynamics, okay. Thermodynamics, so yeah, you attended the classes, no?
Yes, sir.
Okay, thermodynamics, okay. Then thermodynamics I will not do in offline classes if you guys start coming, okay? So I'll not do that, okay? So we have to cover up, no? So other topics I can touch, okay, when you start coming. Okay, okay.
So tomorrow at what time?
Tomorrow at what time? Tomorrow at what time? So yeah, guys, can you just decide very quickly today only? 11 a.m. is fine.
Okay.
Let me check. Tomorrow is what? 27th. I am okay. I am okay with 11 a.m. Those who want to come. Okay. Those who want to come at 11 a.m. Anybody has problem, you let me know right now, okay? Who is coming, by the way? Abhijit is coming. Yeah, Ishita and all, they are coming. Okay, fine. Okay, so please discuss in the group and come, okay? Just come and roam and go, no? What's there, no? Okay, then yeah, that's it. Then Thursday to at evening to we have only, right? Thursday, yeah. Tomorrow to we have only. Tomorrow at what time? 8 p.m. no? That to we have only, okay? So okay. So we'll do this, okay? Then in Elishaba school, okay? Any idea? Will they reach this topic or not? Oscillations and wave. Your teacher said something.
So I'm not sure.
You're not sure, no? So, okay. They did not say anything about the course till now, no?
No, sir. Oh, I think he sent the syllabus.
He has sent the syllabus. Okay, you please send to me also, huh? I'll check.
Yes, sir.
Okay, I'll check that. Okay. Then any other school? Okay, maybe some Amboss schools, no? Like yeah. Okay, let me just stop the record.